Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. We will continue with the gas, one phase gas. So if you see the schedule here, you see that we goes to, this is for class A and class C. Okay, and meanwhile for class B will be continued by Ibu Buri. So we continue with one phase gas, and then for today is one phase gas, and then follow next week flash calculation and introduction of two-phase flow. As mentioned, probably explained in one phase oil. So the whole thing, the whole flow in the pipe is for oil. Previously is for oil, but right now is the whole inside the pipe is fully the gas. Before we continue with the gas flow in the pipe, so we would like to see what is the Reynolds number for the gas, because it's different as compared to oil, as the oil is the density and viscosity doesn't depend on pressure and temperature much, as compared to gas is the gas density and viscosity depends on the pressure and temperature. So let's continue with this one. So we would like to have a calculation for gas. This is for oil, okay? So let's see. For the regas, what we have is PV, Z, and RT. You know everything. This is a dimension in here. It mentioned that V is feet cube, pressure psi, Z dimensionless, N is a pound mole, and R is 10.732 psi feet cube per pound mass mole, the Rankine, and T is in Rankine. And remember that this one is for field unit, okay? Do not change to the SI unit. And as you see, the the pound mole is M for M. The mole of the mass and the mole, the mass of the gas and the mole of the gas. So we arrange everything, and density is a mass of the gas divided by the volume. So finally we have a density is P, pressure multiplied by mole of the gas divided by the Z, R, and T. And we see the unit analysis. The first day of school of Transmigas, we have a unit analysis. So we'll see that the unit of this one, M is PSIA, P is PSIA, M is pound mass per pound mole of mole, Z dimensionless, R is PSI feet cube, pound mole degree Rankine, and temperature is degree Rankine. Remember, temperature is degree Rankine, okay? And we have this equation. Remember that M of equal to 29.2897 or something, 29, to be exact is 2897, but we can use 29 of density of a gas. So we have this equation, so we end up with this equation. And then we see the velocity. We want the velocity is in cubic feet. So this is the way we convert the unit. So velocity q divided by e. Q we want a MSFD and MSFD, and we continue with everything else. So we end up with this number q divided by d over 2 in feet per second. So we plug in everything from this Reynolds number 1488, rho Vd over mu. This is the density, this velocity, d is in feet, okay, d over 12, and this density. So we end up with having this equation. Remember this equation, which is if we have a standard of 14.7 and 60 degree, we have this Reynolds number 20 q gamma g mu d. Remember that we are evaluating in the pressure and temperature, which is higher, usually higher than these two. Okay. So if you have any question, just ask on the Google Scholar, okay, or on the group WA. That's it for the Reynolds number.